Hello everyone, today we're talking about the trigonometric graphs. So now we're talking about the graphs of our sine and cosine functions in section 5.3. So to start, we have the general graphs for sine y equals a sine kx and y equals a cosine kx. You'll see what the k and the a stand for. Make sure you know that amplitude is always positive. So even if this is a negative value, you'll see what the negative value does to the graph. But just realize your amplitude is always positive, and your period is how long it takes for one complete sine or cosine graph, and you'll see what I mean by that. And the period is 2 pi divided by k, and then k is whatever's in front of our x and our sine and cosine functions. So let's see the basic sine and cosine function. So you'll see a basic sine function has one period. So we've completed a sine graph right here. So the generic basic sine graph looks like that, where it starts at 0 pi, reaches the amplitude at pi over 2, back on the x-axis at pi, back at now at the negative amplitude at 3 pi over 2, so the third interval, and then the final interval completes its period at 2 pi back at the x-axis, back at the horizontal axis. The cosine graph just starts at the positive amplitude, crosses the x-axis at the first interval, at the negative amplitude at the second interval, at the x-axis again the third interval, and back up to the positive amplitude at the last interval. You'll notice that the sine and the cosine graph, they look very similar, right? So the cosine graph is just shifted pi over 2 compared to the sine graph. So they're very similar, but their starting points is basically the only difference between the two. So let's go ahead and start graphing the different sine and cosine graphs. So every single time when we start to graph a trig function, we're going to write down A for our amplitude, P for our period, and maybe for the first time I'll write down what they actually stand for. So A for our amplitude, P for our period, vertical shift, horizontal shift, and then the interval. And that's what I was talking about in the basic graphs. The interval, that's when our most important points of our trig functions are going to happen on the intervals. And vertical and horizontal shifts, just like we've been doing before with the transformations. So it's the same kind of thing with the vertical and horizontal shift. So in this one, our amplitude is whatever's in front of our cosine. So here there's nothing in front of our cosine, so we're going to say our amplitude is 1, which is the same as the basic cosine graph. The period is, and I'm going to do this in a different, 2 pi over k, where k is the number in front of my x, no number in front of my x, so we'll assume it's a 1, so the period is 2 pi, just like the basic cosine graph. Now where this one differs from the basic cosine graph is we have a vertical shift, right? We have a vertical shift of -2, because we're adding a -2 to our graph. So we're going down 2. We're shifting our normal cosine graph down 2. Horizontal shift, there's nothing adding or subtracted with our x, so there's none. And our interval is always our period divided by 4, because there's 4 intervals in each sine and cosine graph in each period. And this is a lot of information, I know, but as I go through the examples, these will start to make sense. So my period was 2 pi, so I'm counting by pi over 2. Each interval is going to cover pi over 2 radians. So now we have all the information we need to go ahead and start the cosine graph. So our amplitude is 1. So I will count by ones. But we can see that our graph has been shifted down too. So I like to draw like the new x-axis. I've shifted my x-axis down 2. So I like to draw that new x-axis to see, so that it's easier to draw my cosine graph. Okay, and then the next thing I want to draw is I want to draw my intervals. So I haven't shifted left or right, so that's cool. So I start at 0. So that means my first interval is going to be pi over 2, right? Because I'm counting each by pi over 2. The next one would be 2 pi over 2, right? I'm counting by pi over 2s. So this is 1 pi over 2, 2 pi over 2. Next would be 3 pi over 2, and the final would be 4 pi over 2. And we know that this simplifies down to pi, this simplifies down to 2 pi, but just for the first example, I want to show you that I'm counting by pi over 2s. It's real easy to draw the intervals. And then I'm going to draw a dotted line here just for the first couple until we realize what is happening at these intervals. So, if we look at our basic cosine graph, right, we haven't shifted left or right, so our basic cosine graph is going to start at the positive amplitude. So, let me do it in a different color. Since we're starting at 0, we haven't shifted left or right, and the amplitude is 1. Our cosine graph starts at -1, because our amplitude is 1. This is like our new x-axis, remember, because we shifted down 2. At the first interval, the cosine crosses the new x-axis, and you can go back and check the basic cosine graph to show that that's correct. At the second interval, now I'm at the negative amplitude. At the third interval, I'm back at the x-axis. And then at the fourth interval, the last interval, I'm now back at the positive amplitude. So my cosine graph looks like that. And all we need to do is draw one period. So my cosine graph started, ended. One period, that's all we need to worry about drawing. So there is y equals -2 plus cosine of x. Now let's work on a sine graph. So again, we're always going to start with our amplitude, period, vertical shift, horizontal shift, and interval. So, amplitude, there's nothing in front of my sine, it's a -1, but remember amplitude always has to be positive, amplitude is 1. Period is 2 pi over k. Well, my k in this example is 2. So 2 pi over 2, meaning my full sine graph is going to have to fit in pi radians. The other one was 2 pi. So this one's going to be squished a little bit. It's got to finish quicker. No vertical shift, we're not adding any numbers. And no horizontal shift, we're not adding anything to the x. So then my intervals is the period divided by 4, so that's pi over 4. So I'm counting each interval is going to be pi over 4, where the first example was pi over 2. So go ahead and draw your axes. Okay, we haven't shifted up or down, so I'm going to stay right on my x-axis. Then I'm going to draw my intervals. Right, so first one's pi over 4. The next one would be 2 pi over 4, or pi over 2, right, if I simplify it. Next one would be 3 pi over 4, and the last one would be 4 pi over 4, or just pi. And that makes sense because my period has to end in pi radians. So now, let's go ahead and draw, I'm going to draw these horizontal one more time just to show you that something important is happening at these points. So those are just there as a drawing aid. They're not actually on the graph. So when I eventually have you guys drawing these, you don't have to draw those horizontal, those vertical lines. I'm just doing it just to show you that those are important points, those intervals. And the key thing here is there's a negative sign. So that just means, right, when we have a negative out in front, I'm flipping over the x-axis. So it's still going to start at 0 because I haven't shifted left or right. But instead of like the original, where it goes up first, the negative is just going to go down first. So I know at the first interval, and the amplitude was 1, so I know I'm going to hit 1 and -1. So at the first interval, I hit my negative amplitude. Second interval, I'm on the x-axis. Third interval, I'm at the positive amplitude. Fourth interval, I'm back on the x-axis. So my sine graph looks like that, and I've completed one period. I've completed one full rotation. And you can see that if I took this and moved it over, I'd have a circle, right? Because the sine and cosine are just graphic examples of the unit circle. So one period is a circle. And you'll see if you just took that, slid it over, it'd make a circle. Okay, so every single time we're going to do these 5 steps, even if they're not there. And there is our negative sign of 2x. 2x meaning it's squished in. Right? It had to complete faster. It had to complete in pi radians instead of 2 pi like the first one. Next one, now we start to get a little bit tougher. Our amplitude, period, vertical shift, horizontal shift, intervals. Okay, there's nothing in front of our sine, so our amplitude is going to be 1. Period is 2 pi over k. Well, in this example, our k is 1/2. So I get 2 pi over 1/2. So if I flip and multiply, I get 4 pi. So this one's stretched out, right? It's a horizontal stretch because I have multiplied by a fraction. So now this one takes a longer time to complete that one period. Vertical shift, there's nothing being added on the outside, so none. But this one we do have a horizontal shift because we have that pi over 4 being added in with our x. So, and when it's positive in with our x means we do the opposite. So we go left, pi over 4. And our interval, so it's pi over 4, or I'm sorry, the period over 4. So 4 pi over 4, meaning we're counting by pi. So each interval now is stretched out to where each interval is pi. So let's go ahead, draw our axes. We haven't shifted up or down, so it's going to stay on the x-axis, but we did shift left pi over 4. So we've shifted left pi over 4, meaning that our sine graph, since it's not shifted up or down, is going to start there. My amplitude is 1. So I'm going to hit 1 and -1 when I reach those critical intervals. And now since I shifted left pi over 4, I'm at negative pi over 4. And hopefully you can see that one interval would then be 3 pi over 4. Right? Because I'm counting by pi. So I had a negative pi over 4. So at 3 pi over 4, I have to reach my first interval. And I'll draw that drawing aid again to show you that at 3 pi over 4, I'm at my first interval. That's my first key point. So I have gone pi units because I was at negative pi over 4. So if I add 3 pi over 4, now I'm at 4 pi over 4. I'm at pi. So now again, I'm adding 4 pi over 4. So I'm at 7 pi over 4. I'm just adding pi units to each one of these. These horizontal shifts can be tough to imagine, but I've just shifted left pi over 4, so each one is going to be off by pi over 4. Then I'm going to add 4 pi over 4 again, so I'm 11 pi over 4. I know another important interval takes place there. And finally, 15 pi over 4 is where my first period will end for this sine graph. So, I haven't shifted up or down, but I did shift left. So I know at my first interval, doesn't matter what these numbers are, just think about them in terms of intervals. There's 4 intervals. So at my first interval, not on the y-axis anymore, my first interval is where I reach my positive amplitude. My second interval, I'm back on the x-axis. My third interval, now I'm at the negative amplitude. And my fourth interval, I'm back on the x-axis. And my sine graph still looks like that. So our sine and cosine graphs are always going to look like that. What's going to change is whether or not they're on the x-axis, if I have a vertical shift or not, and whether or not they start at the y-axis, right? Whether or not I have a horizontal shift or not. But the graphs are going to basically look the same. We're just going to have to make sure we find these intervals. And yes, you will have to find those intervals. Finally, and every single time we write these down, every time when you go to draw one, I'm going to ask you where are your 5 key points, right? So these should be written down every time. Okay, so we have a negative out in front, okay, but our amplitude has to always be positive, so our amplitude is 1/2, but that negative we should know now is going to flip us over the x-axis. Our period, okay, so this one is a little bit tricky because our period is whatever's being multiplied by our x, but here we have to be careful, right, because the 2x is inside the parentheses with the x. It's not being multiplied by our x term like the previous one was. See how this 1/2 is outside of the x? I can't have a 2 in front of my x inside those parentheses. So I had to distribute a 2 out. So to distribute the 2 out, right, I'm just dividing by 2. So my function really is y equals negative 1/2 cosine 2 times x, because now I have an x all by itself, but that's minus pi over 4. So I take pi over 2, and I divide that by 2, right? Because I'm dividing both sides by 2 when I pull a 2 out. When I factor that 2 out, it means I'm dividing both sides by 2, and that's the same as pi over 2 times 1/2, right? Because this is really 2 over 1. I just flipped and multiply. That's how I get pi over 4. So my period is 2 pi over k. In this case, k is 2. So I get pi. Let me write one more intermediate step. So you see where I'm getting that. Vertical shift. I haven't added or subtracted anything on the outside of my trig function. So again, no vertical shift. Horizontal shift though, since it's negative in with my x, means I'm shifting positive right, pi over 4. And my interval is always period divided by 4, so in this case, pi over 4. So let's go ahead and draw our axes. Okay, I'm going to start with vertical shift. No, nothing. It stays on the x-axis. I did have a horizontal shift though, so I know my graph is going to start at a positive pi over 4 because it shifted right 4. Okay, I know that my amplitude is 1/2, so I'm going to have an amplitude of 1/2, and I can just draw it like this. I don't have to, draw a 1 and show it in between it. I can just say, okay, my amplitude's 1/2, so negative 1/2 is my negative amplitude. And my interval that I'm counting by is pi over 4. So that means my next interval would be 2 pi over 4, then 3 pi over 4, then 4 pi over 4, and finally 5 pi over 4, because I need to cover 1 pi for my period. So remember, I shifted right pi over 4, so now 4 pi over 4 is pi, takes place from pi over 4 to 5 pi over 4. So now I'm good to go ahead and draw this. I have to remember that I had a negative in front of my cosine. So instead of starting at the positive amplitude like it does in our basic graph, it's going to start at the negative amplitude. And since I shifted pi over 4 to the right, I start down here at negative 1/2. Right? The negative means I flip it over the x-axis. So at the first interval now, because I've shifted pi over 4 because of this, I'm at negative 1/2. My second interval, I'm at the x-axis. My third interval, I'm at the positive amplitude. Fourth interval, back at the x-axis. Third interval, and fourth interval, final interval, I'm back at negative 1/2. So I start here because I shifted pi over 4 to the right, and then my cosine graph is right there, and you can see that that's just the regular cosine graph flipped over the x-axis. So a lot of information here, I know. Go ahead and try the example problems. And like I promised, the few original graphs and the basic equation are all in the PowerPoints, so you don't have to try to see these if these are blurry or anything. So try the example problems, try them, and we'll discuss them tomorrow beginning of class.